So what if I told you there's this secret formula for solving systems of equations? A method that's so elegant, so systematic, it feels like you're unlocking a hidden pattern in the numbers. Well, today, we're diving right into it.
Yeah, we've all been there, right? You've got two variables, say x and y, all tangled up in a couple of equations. How in the world do you find that one single point where both of their lines meet? Now, there are a few ways to do it, but the method we're going to explore today is just exceptionally clean.
But here's where it gets really cool. This isn't just for your math homework. What if this exact same math is the key to cracking secret codes? Because, well, it is.
Yep, you heard that right. The very same logic that finds where two lines cross paths can also be used to encrypt and decrypt really sensitive information. And the key to the whole thing is a single, powerful number.
This is the real-world application. Think about it. Data is scrambled up into a grid of numbers, a matrix. To unscramble it, to decrypt it, you need the right key. And that key? It's a special number called the determinant. Understanding that is our very first step.
All right, so let's get to it. Let's meet the star of the show, the determinant. It might just look like a single number, but believe me, it holds a surprising amount of information about our equations.
For a simple 2x2 grid of numbers, finding this magic number is incredibly simple. The formula is just AD minus BC. All that means is you multiply the diagonals and then find the difference. Let me show you exactly what I mean.
It's really just a simple three-step move. First, you multiply down one diagonal. Then, you multiply up the other diagonal. And for the grand finale, you subtract that second number from the first. That's it. That's the whole pattern.
Okay, let's try it out with this matrix here. First, we're going to multiply down. 5 times 3, that's 15. Easy enough. Then we multiply up. -6 times 2 gives us -12. So the last step is just to subtract that second number from the first. We've got 15 minus a -12.
And what does that give us? Well, 15 minus -12 is 27. So for this particular matrix, our magic number, the determinant, is 27. Now hang on to that number because it's about to become really, really important.
Okay, so now that we know how to find the determinant, we can unlock the main event. We're talking about a super powerful technique called Cramer's rule.
And get this. This isn't some brand new trick. This rule was introduced way back in 1750 by a Swiss mathematician named Gabriel Cramer. It's just a beautiful, elegant solution that's been around for centuries.
So what is it? Honestly, the best way to think about Cramer's rule is like a recipe. To find x, you just find a special x determinant and divide it by the main one. You do the exact same thing for y. It's this brilliant little trick that turns a messy algebra problem into just basic division.
All right, enough talk. Let's actually put this recipe to the test with a real example and see how slick it is. Okay, step 1. We need our main determinant, which we'll just call D. To get it, we build a matrix using only the numbers in front of x and y, the coefficients. So for this system, we'll grab the 12, the 3, the 2, and the -3. Now we just do that little diagonal dance again. 12 times -3 minus 2 times 3. That gives us -36 minus 6, which is -42. And there's our main determinant, D. That's going to be the number on the bottom of our fractions.
Okay, now here comes the really clever part. To find the special x determinant, or dx, we take that original matrix, but we're going to swap out the x column, that's the 12 and the 2, with the answers from our equations, the 15 and 13.
And we just run the same calculation on this new grid. 15 times -3 minus 13 times 3. That's -45 minus 39, which gets us to -84. And that is our dx. See? We're almost done.
I bet you can guess what's next. To find did y, we go back to our original matrix, and this time we replace the y column with those answers, the 15 and the 13. All right, one last determinant to calculate. 12 times 13 minus 2 times 15. So that's 156 minus 30, which is 126. Okay, we have all three of our magic numbers, d, dx, and dy. And now for the big payoff. We just plug everything into our recipe. For x, we take dx and divide it by d. -84 divided by -42, that's a clean 2. For y, we take dy and divide it by d. 126 divided by -42 is -3. And boom, just like that, we have our solution. The point where these two lines cross is 2, -3.
Now, Cramer's rule is amazing, but it does have one little catch. What happens when our main determinant, d, isn't just some regular number?
What if d turns out to be 0? I mean, we all learned you can't divide by 0, right? But this isn't a mistake. It's actually the math sending us a very important signal about our equations.
When that main determinant is 0, it just means there's no single unique answer. It's telling us one of two things. Either our lines are parallel, meaning they never ever cross, or they are the exact same line, stacked right on top of each other with infinite solutions. Either way, Cramer's rule flags it for us instantly.
So let's wrap this up. Cramer's rule is this awesome formula-based way to solve systems of equations. It all hinges on calculating these magic numbers called determinants. And the key trick, the real secret sauce, is swapping out a variables column with the answer column. And remember, if that main determinant ends up being 0, it's like a built-in alarm system telling you there's no single solution.
It's just wild to think that this incredibly elegant rule comes all the way from 1750. You know, it really makes you wonder, what other complex problems out there in our world today are just waiting for somebody to spot the hidden pattern that solves the whole thing?